Pascal's law deals with the pressure related to the static fluid from various directions. Knowing pressure of static fluid is important in designing of dam, hydraulic cranes, etc. Pascal's law states that a change in pressure at any point in an enclosed fluid at rest is transmitted undiminished to all points in the fluid. It was derived by French mathematician Blaise Pascal in 1647. To understand it in a simple way, let us consider the water in cylinder at rest. At the molecular level, water molecules are at rest for now. If we apply pressure on one of the molecules, it will exert the same pressure in all directions. The changes will be same in the all directions. Let us understand this mathematically, considering water molecule of wedge shape. Pressure Px, Py, and Pz are the pressures acting on the plane dy, dx, and dz acting respectively. As we know, force is equal to pressure into area. We can write force in x direction, Fx is equal to pressure Px, into area dy into 1. As similarly, force in the y direction is equal to Py into area dx into 1, and force in the z direction is equal to Pz into area dz into 1. We can resolve pressure Pz into two components, namely, Pz sine theta, and Pz cos theta. As this element is very small, we can neglect its weight. As we know, fluid element is in equilibrium condition, we can apply the conditions of equilibrium here. As we know, in equilibrium, the sum of all the forces acting in horizontal directions and vertical directions is 0. Applying first condition, we can write Px into dy, minus Pz into dz into sine theta. By using trigonometric formulas, we know dz into sine theta is equal to dy. Hence, substituting these values we get Px into dy equal to Pz into dy. Cancelling dy, we get Px is equal to Pz. Applying second condition of equilibrium, we get Py into dx minus Pz, into dz into cos theta. As we know, dz into cos theta is equal to dx. Cancelling the term dx, we get Py is equal to Pz. From equation 1 and 2 we can write Px is equals to Py equals to Pz. This implies that the pressure exerted by an fluid element is equal in all the directions. Let us take an example to understand it. Consider a glass tube containing liquid, and attached to the piston on one side, the water level in all the tubes is same. When piston is pushed inside of tube, water level starts rising in 3 of the tubes. The water level rises in all tubes, but remains same, implying that fluid applies same pressure everywhere. Hydraulic jack is one of the applications of Pascal's law. Applying force on the left side of the piston results in lift of right-hand side piston, having higher cross-section area. As stated in Pascal's law, pressure exerted by fluid element is same in every direction. We can write it as Px is equal to the Py. We can also write it as Fx by Ax is equals to Fy by By. As Ax is lesser than Ay, we can say that the force required to lift the car will be lower than the force required with other techniques. This law can also observed in hydraulic cranes, hydraulic lifts, etc. It reduces human efforts, as well as useful to determine static fluid pressure.